What is the number of ordered triplets ABC of positive integers with A is less than or equal to B, is less than or equal to C, and is less than or equal to 9, such that there exists a non-degenerate triangle ABC with integer in radius, for which ABC are the lengths of the altitudes from A to BC, B to AC, C to AB, respectively. Recall the radius of a triangle is the radius of the largest possible circle that can be inscribed in a triangle. Right, so let's denote in circle by R. So we're going to write down the area in different ways and then find the relation between ABC and R. So if we denote the area of the triangle by S, on the one hand, S is 1/2 A times BC. This equals 1/2 B times AC. This equals 1/2 C times AB. And this equals 1/2 times the perimeter, which we denote by S, times R. From here, we can write down AB, AC, and BC. So AB is actually 2S over C, and AC is 2S over B, and BC is 2S over A. Okay, and then writing S, which is AB plus AC plus BC, and then set the areas equal to each other, we get S equals 1/2 AB plus AC plus BC. You can just write it from here, and then we can pull out 2S. So this is 2S, 1 over A plus 1 over B plus 1 over C times R is their area. Hence, we can cancel out S, and then we get and we can also cancel out 2's, and we get the relation between ABC and R. The relation is 1 over R equals 1 over A plus 1 over B plus 1 over C. Okay, and we want to find the solutions for which ABC satisfy this inequality. But we also can use something. So we're going to do a casework, but in order to reduce the cases, we're going to make some observations about R and the numbers ABC. Okay, first of all, observe that from triangle inequality, we obtain something. So triangle inequality, we have BC is less than AB plus AC. And substituting these quantities, we get 2S over A is less than 2S over B plus 2S over C, hence 1 over A is less than 1 over B plus 1 over C. Okay. Adding 1 over A to both sides, we get 2 over A is less than 1 over A plus 1 over B plus 1 over C. This is R. Hence, we get, I'm sorry, this is 1 over R. We get 2R is less than A. Okay, so this is the first equation that we get, or inequality that we get. And we can obtain another inequalities from here. So 1 over R is greater or equal to than 3 over C, and less than or equal to 3 over A. Since A is the smallest and C is the largest, hence from here we obtain A is less than or equal to 3R is less than or equal to C. Okay, and we also know that C is less than or equal to 9, and A is from previous inequalities greater than or equal to 2R. Okay, so this is the nice inequality that we can use in our casework analysis, right? So now let's do a casework on the number of, on the values of R. So casework, let's write it here. Casework on, okay, first the equation is 1 over R equals 1 over A plus 1 over B plus 1 over C. Second, the inequalities are 2R is less than A, less than or equal to 3R, less than or equal to C, less than or equal to 9. So from this inequality, we immediately obtain that R is less than or equal to 3. And since triangle is non-degenerate, this has to be greater than or equal to 1. So let's start with the first case, and r equals 1. Okay, and then in that case, we get, in that case, a is automatically, a is greater than 2, less than or equal to 3. So a has to be equal to 3, and b is greater or equal to 3, c is greater or equal to 3. Hence, 1 over a plus 1 over b plus 1 over c is less than or equal to 3 over 3, which is 1. But this is 1 over r, and this is 1. So the inequalities are indeed equalities. So we get the case a equals 3, b equals 3, and c equals 3. So this is the first solution from the very first case. Okay, now let's work the case r equals 2. Again, a is now between 4, greater than 4, right? And this a less than or equal to 6. Okay, so let's do a subcase analysis, and a equals 5. Then we have 1 over 2 minus 1 over 5 equals 1 over b plus 1 over c. All right, and then working this, we have 3 over 10 equals b plus c over b, bc. So we do a Simon favorite factoring trick, multiply the cross multiply, so we get 3bc equals 10b plus 10c. Multiply both sides by 3, and then subtract right from the left. We get 3 squared bc minus 30b minus 30c equals 0. Or this is 3b minus 10, 3b plus 10 minus 10 equals 10 squared. Okay, now, or actually the next term is 3c minus 10. So since c is less than or equal to 9, 3c minus 10 is less than or equal to 17, and b is greater or equal to than a, and a is 5. This is greater than or equal to 5. Okay, so two numbers multiply to 100 square, and one of them is greater than or equal to 5, and the other is less than or equal to 17. The only solution is 10, 10. But in that case, c is not an integer. Okay, and then this doesn't give us a solution, right? And then now let's continue with the next subcase. So 2 r equals 2. And in this case, in the second case, a equals 6. And then we know that b is at least 6 and c is at least 6. And since 1 over a plus 1 over b plus 1 over c, in this case, is less than or equal to 3 over 6. This is 1 over 2. But in this case, this equals 1 over r. Hence, inequalities are indeed equalities. Hence, a equals 6, b equals 6, c equals 6 is the second solution. Right? So let's work the third case when r equals 3. In that case, the equation is indeed 1 over 3. Oh, yeah, we also need to do subcases. Okay, so let's work this subcase when, first let's write down the inequality. So a is greater than 2a, which is greater than 6, less than or equal to 3a, is less than or equal to 9. Okay, so this is important. So let's start with a equals 7. In that case, the main equation is 1/3 minus 1 over 7 equals 1 over b plus 1 over c. And this is 4 over 21 is indeed 1 over b plus 1 over c. We do the same Simon favorite factoring trick step here, and then we obtain 4b minus 21 times 4c minus 21 equals 21 squared. Right? And observe that c is less than or equal to 9, hence this is 36 minus 21, so this part is less than or equal to 15. So is this part, right? So this is less than or equal to 15 because b is smaller than or equal to c, hence this gives us no solution, right? So let's work the second subcase when a equals 8. Similarly, the equality becomes 1/3 minus 1 over 8 equals 1 over b plus 1 over c. And then this is 5 over 24 equals 1 over b plus 1 over c. And then again, Simon's favorite factoring trick step yields, this is 5b minus 24 times 5c minus 24 equals 24 squared. Okay, again, we do the analysis. C is less than or equal to 9. So this is 45 minus 24. This is at most 21. It's less than or equal to 21. And since B is smaller than C, this is less than or equal to 21. Two numbers cannot multiply to 24 squared, so this does not give us any solution. The third subcase is, let's write down, so R equals 3 and C equals 9, okay? In that case, B is greater or equal than 9, C is greater or equal than 9, but these are all at most 9, hence we have A equals 9, equals B equals C, and then we see that this indeed works and R equals 3, right? As this is the third solution that we have, in total we have three solutions. And our answer is B3.